Hello. Oh boy, it's Friday. I completely forgot to put up the Friday thing. Oh well, that's fine. Okay. Let's put on some music. Okay. So, as I said yesterday, today we're going to start out with this new UI toolkit. Now, I'm fairly sure the stream today will be... Well, we won't get anything visible done, so to speak. We won't be able to test anything. I'll just be hammering out the core protocol that I jolted down on paper here. And I'll discuss things along the way and also need to think about potential problems as they come up and solutions to those. So, if you may remember the previous stream I did on this, there's essentially four, five, depends on how you cut it, but there are several parts of this system. One part of it is the focus management, the other is the layouting, and then you have the renderer that actually takes care of drawing. And I think the first one I'm going to tackle is the focus part, which is a focus tree, so to speak, or that's going to be our basic element here. Alright, give me a minute to fix this to my monitor so I can actually see it at all times. If you are interested in design and software engineering, and you need to think about a system, I heavily recommend not sitting at the computer to do it. Take a piece of paper and just start scribbling. Scribble down names, functions, graphs of how things work, how to fit together, data types, and so forth. It's much easier than trying to type things out. And then, once you got the paper together, that sort of has everything you think you're gonna need, you just put that paper on your monitor and start writing things out. Okay, so we're gonna have a couple of classes that are part of the focus stuff. We are gonna have a focus element, which is our base class for this, and we're gonna have a class for a focus entry and a focus list, and we're gonna have a focus tree. Focus list is a focus element, as is the entry, and this one is, in addition to that, a container. We also make a new file for the container class, since that's going to be a protocol that's shared between the layout and the focus parts. Okay. Alright. Our focus tree is going to have a root, and it's going to be, well, and a focused element, or, yeah, and an element table. I'm going to talk about what it is, or what each of these things are, and how they behave in a while. First, want to get things down on the screen so I can actually talk about them a bit more easily. So you're going to have to be patient for a bit while I type this stuff out. No, this is... Now, fortunately for us, class is a pretty good modeling language for protocols, so it should be fairly easy for me to write all this down and then talk about it henceforth. Let me also hammer this out. Okay. So the first thing, I guess, to talk about would be the container class, which is really simple. It represents a container of elements, and this container may associate several properties to an element that has been added, and it may not support adding the same element multiple times, however. So when you add an element to the container, you just specify these two parameters, but you may also specify additional parameters that may or may not be required to further specify how the element is added to the container. The reason this is important is because this is the same mechanism that's used for, say, the layout, where you might want to pass layout parameters along with the element to specify how it is arranged. Then there you have the opposite, which simply removes the element from the container, and an update function which allows you to change the properties you set when calling enter. So that's a pretty simple basic abstraction. As you can see, while we're hammering out this protocol, there's no code that actually does anything. That's going to be afterwards. First, we're remaining on this sort of much more abstract, restrained view, where we're only thinking about data types, fields, and generic functions that act upon these data types. Okay, moving on to the actual focus part. This is the core protocol that's a part of this. So At the most basic, we have a focus element. A focus element is an object that's within a focus tree. This may or may not be something that is visually displayed. If it is, then it should be a focus entry, and it has an associated component that is displayed. So this is where one of the differences in this toolkit comes in compared to other toolkits, more contemporary toolkits for UIs, which is that there is no single hierarchy of components that are displayed, neither for the layouts nor for how things are focused, meaning that the component itself is only ever a leaf element, meaning something like a text box or a button or a text field or some kind of label or an icon or, you know, a radio button or maybe some kind of slider, something like that. Something that does not have any further things inside of it. Okay. So, because there can be multiple focus trees and multiple layouts, this means that one such component has no information associated with whether it is currently focused or not, or what kind of parent it has in the hierarchy, or whatever, because it might have multiple of those at the same time, or different states of focus at the same time, depending on where we are. For instance, you might have a component that represents, I don't know, let's say the username, and you might have multiple windows that display this component at the same time, or multiple parts of a layout, and it might have focus in one part but not in another. So that's why there is a focus element which holds this actual property as well as the parent within this focus tree, and we have a focus entry which we actually create for each component that should receive focus in this hierarchy, and this is also, of course, a focus element. Then this parent always points upwards in the hierarchy, so it's a directed acyclic graph, which makes sense because cyclic graphs would confuse the bejeebus out of people. So I'm quite happy with making things directed. So basically a tree, you know. Well, actually, it isn't a DAG, it's a strict tree, meaning there is no directed cycles either. Okay, the focus property can be one of three states. It can be either weak, strong, or nil. Nil meaning no focus at all, strong meaning the element is actually focused right now, and weak meaning it is sort of selected or currently hovering over it or something like that. Some kind of transient state where it's not fully focused, so it doesn't receive events directly, but it is sort of selected-ish. Okay, and then we have three functions that can operate on this focus element aside from the container things. Exit means that if the element currently has focus, it redirects the focus up to its current parent element. Meaning that, for instance, on a phone, if you press the back button, then the focus goes outwards one, and that's sort of the same idea here. The opposite of this is activate. If a focus element is activated, it receives focus. And finally, we have a handle function, which is dealing with events and the propagation or dealing thereof. Okay, we've already gone over the focus entry, so let's go to focus list. A focus list is a list or a container for multiple focus elements, and this is used to group elements together and let you cycle through them in one continuous list. again, remember that this has nothing to do with the layout or the display of things. This is purely how event focus is managed and how to determine what the user is currently selecting or not. So it doesn't have to have anything to do with how it's displayed. In the end, it's purely thought for how to navigate the UI space using a keyboard, a mouse, or a gamepad, or whatever you have. Right, so the focus list simply stores the number of children, and it gives you a focused function which tells you which of the current children is focused. So it gives you the entry of the currently focused one. This may be a weakly focused element, so if the element does not have strong focus, it's only sort of semi-transient selected, it'll still give you that element. Or in the very least, I think that's the right approach to take for this protocol. And then focus next and focus previous simply shift the weak focus to the next or the previous one if there is no strongly focused one. So if we're currently in the active focus list, or maybe it should force it. Yeah, probably better. So this steals focus away and puts it into the next one. Okay. I think one thing we need, though, just for efficiency's sake, is a focus tree link so that the element can quickly update this slot here, which tells us the actually strongly focused element within the entirety of the tree. So that when the element is changed, we can update that without having to traverse upwards in the tree and find the tree root. Okay, that brings us directly to the focus tree itself, which is a sort of an aggregate class or type, which has the root, which is a focus element that sits at the root of everything. It has a focused pointer, which gives us the currently strongly focused element, and it has an element table, which is the inverse mapping of components to focus entries. So, using this table, we can then retrieve the actual focus element that represents a component in a given focus tree. All clear? Also, my birds are loud because I have to have the lights on today because I need to read my notes, and because they've been very tired or very bored all the day. I've had my blinds down due to the heat. They're going to be loud. My apologies.
Focus flows up. Clear.
Focus flows up. What do you mean? Now I'm not clear on what you mean. One thing is also we might actually have instead of a focus list, we might have a focus grid as well, where there is no clear next or previous, but rather things can go two-dimensional. So I think that's a good addition. Probably actually, whoops, make the focused one a pointer here as well. maybe we can make this a focus list after all, and it'll just proceed row-wise otherwise. Lisp is asking, do you have any thoughts on functional versus object-oriented programming? Well, both of those things are very ill-defined. There's very different flavors of object-oriented and functional programming. So it's kind of hard to know what you mean. And I feel like any kind of answer I would give to this would be a bad one, because I would be making assumptions that are not necessarily there, or I will be making assumptions that are not clear about the question. Okay, I think I can make this a focus list as well. No. Better make this separate. Should I? Yeah, probably should. Maybe we should then make a focus chain. Yeah, seems better. Lisp is saying, it looks like you use a lot of object-oriented programming. Often hear functional programming is better, but I really don't understand it. See, this is where you get into the problem of these terms being ill-defined. There's no better. Generally, if someone tells you something is just strictly better than something else, chances are it's not true. Chances are they're either making assumptions that you don't know about what flavor of thing they're talking about, or they have an agenda of some sort and they don't properly understand either domains. So Common Lisp is a multi-paradigm programming language. It has parts that are declarative, it has parts that are object-oriented, it has parts that are procedural, and it's, it has parts that are functional. I like having everything. There's different situations where different things are optimal. And I really, really do appreciate having everything at my disposal. Modern, sort of newish languages tend to go in that direction as well, where they try to support many different paradigms, except for a few things that are just heavily focused on one particular paradigm, and then they're gonna tell you that this is the true paradigm. So just the functional programming thingy alone it's very different whether you have purely functional or just functional, because purely functional is not really about the function so much as it is about side effects free. meaning there is no way to modify something. You can only create new things, and that is what makes that paradigm very different. Functional programming alone only refers to the fact that you have first-class functions, so you can pass around functions as objects, and typically also means closures, so you can create closures at runtime that close over a certain part of the environment. So those are very different things, and I think functional programming is great. It's a super useful tool. Some things can be very, very elegantly written using functional programming. I feel like side effects-free programming has also its use cases, of course, especially when you're talking about safety and reproducibility. But I don't think it's a very good paradigm for a lot of other things. It has some severe restrictions about how you have to do things. The language forces you very much into certain patterns and styles, and I don't like being forced very much, so, you know. But, you know, again, it has its uses. For me, I think object-oriented programming in class style, so the way Common Lisp offers it, which means we have classes, you have serialized inheritance, you have dynamic dispatch, you have multiple dispatch, you have multiple inheritance, and stuff like that, which most languages do not have that advertised to be object-oriented. I think that's an incredibly good paradigm to model protocols and behaviors, and I love it as a design tool. I think it's a very natural way of designing systems and hierarchies and architectures, so I use it a lot for that because that's what I do a lot. Object-oriented programming in the sense of Java and C# and all of those things, I think is mostly, well, nowadays it's not really hyped anymore, but it was hugely overstated how useful it is, and especially the fact that they force you to use classes and methods for everything and there's no functions outside of that is just a mistake. Yeah. It's also the Java C# kind of object-oriented programming. Java C#, C++ kind of thing is just it forces you into a lot of ugly designs because of the restrictions placed, which Common Lisp's object system does not have. So those are some of my thoughts. Anyway, let's see. So we have a focus list and a focus grid and a focus tree, and that should be good now. Alright. Now that we have this, we can start actually implementing things. Which means first setting up these properties. The parent is not... focus tree is not needed. You can just infer that from the parent. In fact, should not have that as an argument at all. Neither should I have this. Wait, did I not? I do have the package, right? Yeah, okay, good. Alright, let's also add a print object function. Okay. That should handle most of the protocol. What the fuck am I doing? There we go, that's the right button. Okay, that should be it. So there's a couple of invariants that I added into this. The first reason for not allowing you to pass a focus tree or focus is because the focus tree is part of an invariant, which means that a focus element needs to be part of the same hierarchy as the rest, which actually means I should also change these to the readers. So when we pass a parent to add this focus element onto, we ensure that it is part of the same focus tree, but simply using the focus tree that's already on the parent to set that. By not allowing you to set the focus initially, actually we could allow that, but we're gonna do it not with an init arc, but simply by saying, whoops, one focus, set a focus element focus. There we go. Actually, we can always set that. That should be safe. Yeah, that should be safe. Okay, good. So this, doing it like this rather than with an init arc, ensures that we always go through the set a focus function, which has a couple of restrictions placed on it. First, we test the validity of our new value here by checking it whether it's nil, weak, or strong. And second, once it's been set, we ensure that the focus tree always has a pointer to our element if we receive strong focus. There's another part of the invariant that needs to be handled here, which has to happen in the set of focus part, which is that this needs to ensure that the previously focused element loses its focus value. So there's another part to that contract that's going to happen later. Finally, the activate and exit functions are pretty simple. On activate, unless we're already focused strongly, we simply set off our focus. And on exit, all we do is, if we're not, if we're sort of focused, either strong or weak, we simply activate our parent. This allows us to actually exit from deeper within the hierarchy, so even if something is strongly focused deep within it, we can exit any parent along the chain and immediately exit to that parent without having to go parent by parent until we arrive at the pump part. So actually I should move these upwards. So like this, I guess. Okay. Now for the focus entry, well, for the focus entry, we need to ensure that it is registered, so after we initialize it, we need to ensure that it is added to the element table in the focus tree. So set up, or should probably add functions for that as well. Maybe probably can reuse enter and exit, enter and leave for that. Yeah, sure. No, I don't like that. Or maybe? I don't know. It's not... No, I don't like it. The element table is also an internal detail, so that should not be exposed. But for protocol purposes... Not sure. Maybe we should have an associate method? No. Doesn't really work with 3. Maybe in the time. Yeah. This kind of table thing needs to happen in the layout as well for the same reason. There we also need an element table. So we're gonna factor that out into another class. Playlisp asks, what is def generic used for? It defines a generic function. Okay, so this is gonna be Good. Okay. So now we can call associate elements with elements in the focus tree of points. And in this case, again, because we're using after methods on initialize instance, here, because this method, this class is more specific, or this method is more specific than this one, we know that the invariant established by this one, namely that we have a focus tree, is already fulfilled once this method is executed. So we're fine with accessing the focus tree. Okay, need to fill this out. Good. Okay. One thing that I definitely need to think about for the future is the question of how this is a data structure question of how to efficiently add and remove elements once things are updated. But for now, I'm not going to worry about it too much. We're just going to use vectors for now. Again, here we're using an initialize instance method rather than directly passing the children so that we can potentially change things and update them properly. So here we're going to use actually use just array, and we're going to make it the same length as the children. There we go. We could also make a shared initialize or a reinitialize instance method that handles the children part as well, so that we have that part of the protocol fulfilled. But that's a bit more annoying, I feel like. Or is it? Yes, it is a bit more involved, but let's do it anyway. What is the difference between methods and functions? Well, functions are what you call, and a function can either be generic or it cannot, or it can be not. So a method is typically not called directly because it requires a certain kind of environment in order to be evaluated or executed. So or let me answer this in a different way. I can either write defun focus next and then implement my behavior here, Or I can write def generic focus next, which defines a generic function. And when you then call focus next, if it is a standard function, then it simply evaluates the code you defined for this function. If you have a generic function and you call that, it uses its required arguments to do a dispatch mechanism and finds the most specific method of all the methods that are attached to the generic function that applies to the given arguments. So more specifically, or more practically, it means a generic function, you can attach methods to a generic function, and these methods can specialize on certain classes, meaning that you can customize the behavior of the function depending on what kinds of arguments are passed. And in the case of designing protocols, using generic functions is useful because it allows the user to extend and change how the protocol behaves by creating a subclass or a separate class and implementing the generic functions that the protocol defines. Because if you are simply a user of this protocol, you typically won't notice, or you aren't allowed to notice, what kinds of exact types you have, but rather you're simply making use of the generic functions the protocol defines, meaning that even if there is an extension present, if you are someone working against the base protocol, it'll work exactly the same way. So that means there's you can compose and extend things in a modular fashion without breaking everything or having to change code that isn't yours. Reusability is sort of one of the main things that object-oriented programming was advertised for back when it was like the fresh Java hype. Unfortunately, the Java model does not really deliver on that. It quickly creates spaghetti, and that's much less so the case with class. At least in my experience, such is the case. Okay. Okay, oops. Alright, so in this function, reinitialize instance is called if you, well, call reinitialize instance on a function, on an object, and typically that allows you to change field values and things like that. And here we allow you to specify which children are in the focus chain, and doing so has a bit of a problem because if the currently focused child is not in the new child array, we need to take care to not lose track of the focus, and we do that here. So we first scan the new child array for the currently focused element, and if we find it, we simply unfocus it and return focus to our current focus chain. And then we change the resident array and copy the elements across. Okay, So now we can implement focus next and focus prev. Let's also put these up here. Should probably also put this needs to be an accessor. Yeah, so here we also need to fulfill another invariant as well. Or do we? No, this is actually fine. Yeah, it's fine as it is. I was wondering whether this focus pointer in a focus chain was a problem when we exit out of a component. I don't think it is, because it also points to a weakly focused element, so that's fine. And it's okay if the weakly focused one stays the same. It's not okay if the focused element is removed entirely. So here we need to just say no. Okay. Alright, you also need to take care of an invariant here. Set focused. There is a bit of a problem though. If we set the focus and the parent doesn't have the focus here. We should probably actually do that. Not here. Or, well, we should put that here as well. So here... there we go. Okay, and in here, actually need to also make sure to update the parent if we have one. Now, whenever you encounter something like this, where you explicitly check for a type in a protocol, it's typically not a good sign, because this is not really extensible. This does not allow the user to change the behavior if necessary, or control it very much, which is bad and might lead to clutches. So I'm thinking about how to remedy this to make it less of a problem. Maybe there should be a notice focus function. Yeah, let's do that. Seems fine. And the default behavior for notice focused. It is just to do nothing because we don't care. Or maybe, actually, no, it shouldn't be. If it is apparent, it should have to implement that. Okay, that's fine. Okay, definite third. Focus chain. Okay. Actually, this should be... should be after both weak and strong focus. You may think this is kind of superfluous, but it is part of ensuring consistency in the protocol, and also part of, well, it's a safety thing, because you don't really know where the flow is going to come from, or, you know, your changes are going to come from. So for instance, you might say, okay, doing all this updating and whatever is not really necessary because the focus change is always going to be done by something else or whatever, but that's not really guarding against user customizations. Namely, it might happen that a user themselves changes the focus on an element directly, and ideally our protocol should then still ensure invariance. To not break apart. There's different schools of thought on this. You can also say that, well, there may be a case that we can't anticipate where breaking the protocol for a short time may be necessary, and in that case, the user should be allowed to do that and sort of escape the automatic shackles the protocol or consistency checks the protocol has in place. So we should do as few tests as possible to allow that. And the other one is, well, we can't really guarantee behavior if the protocol is broken, so we should guard against it as much as possible. Fortunately for us in Lisp, we can do both at the same time. We can implement a safe, guarded protocol using generic functions, and still allow the user to break the protocol momentarily by directly accessing slots instead of going through methods. So by bypassing the generic function protocol and directly going for slot access, you can do the thing you need to without having to muddle around otherwise. And in the typical case where you want these guarantees, they're provided for you as well. In other languages, you typically need to use something like reflection, and that's really ugly and very boilerplatey and very annoying to do. Okay. Notice also that here we're doing several checks on both so that we don't lead to an infinite loop on checking and updating the focus. Okay. So that should give us the implementation of that. Actually, wait, we're lacking the focus next and focus prev. And for this, I think we should have an index along the defocus thingy, just for quicker access. Okay. Again, here we need to ensure consistency. Set of index chain position element. So we should probably do that in the before. Okay. Actually, in this case, we want to bypass the protocol of the index because it would otherwise loop indefinitely. So here we're going to actually use a slot value check. So we're going to be doing a very similar thing on setf index. Oops. Okay. And that should handle that part of the protocol directly. Here, for the next and previous, we're simply doing modulus to loop around. I think that's an okay behavior. Actually, one problem is if there are no children, then we can't focus on next. Question is, should that fail silently? I think it should. Probably always be a safe thing. I also need to take care of not focusing anything. Focus. Okay. I think that's okay. Let me check. Actually, we should always call notice focus on the parent if the focus changes. Not quite sure the invariants here are correct. It is if the focus is changed to strong, but for instance, if it's changed from strong to something else, then it's not necessarily correct because the currently focused one in the thing is... It's not ensured that if we change the focus directly from strong to non-strong, that there is always a strongly focused element in the tree, which I think is an invariant that I really do want. Would be bad not to have a focused one. So what should happen in our game? So obviously set notice focus, but I feel like the only sensible choice is to choose focus to parent. So it's essentially the same as exit. Then that should be an around method probably. Okay. Oh, music ran out. Okay. Let's see here. Start that from the beginning.
Play some NGE.
No. better to not allow it to be no focus nil. If it was previously. Yeah. Okay, so if we're currently the selected element in the chain and the element tries to set itself to focus nil, simply refuse and set it to weak. Because backing out completely and not selecting anything doesn't seem like the appropriate course of action to me. Okay. Okay. Finally, the focus tree itself. One thing I did not yet touch upon is what happens if you activate the focus train again after it's already focused, which is it should then focus the currently weakly selected element. So let's do that. Let's put that in here. Okay. Spin around again. There we go. Okay. Yeah, that seems correct. Good. Goody, goody, good. So now we just need to do that. And these buttons. Okay.
Shin IDK, if you hear this enough, but you're one of the best programmers I know.
Oh shit. I don't. Thank you very much. I'm humbled. I don't know if there's enough. Or rather, like, I feel like even once is probably enough to hear that. I don't know. I'm one of the things I'm scared of is overconfidence and being self-indulgent and things like that. So I don't know if more it would be good for my health. For your health. You know. But thank you, really. I appreciate it a lot.
Your health.
Yeah. Okay. Right, so there's no component yet. You know, Jindrell asks, how do you measure how much is enough? And Eudoxia said, lines of code per unit of time. Oh god. Please. Now, I don't want to be one of the best programmers by that measure. Jeez. Okay, right. one thing I'm kind of afraid of is the measure of what's focused is only, or the contract for what's focused is only upheld by changing the focus on the element itself. It's not actually upheld if you change the focused on the focus tree. So I think I'm gonna add a check for that as well. It's hot. Ugh. I'm breaking out in a sweat now. Right, so that's a check. Whoops. I mean, outside it's probably okay right now. I don't know. Let me actually check if it's cooler already. There's a cold front coming now, which is great. But, it's a bit cooler, maybe? Question mark? I'm not sure. Let me let up the blinds. Bit of a draft in the very least. Ah, that feels nice. Yes. Yeah, storm is coming. Hell yeah. Ah, that's good. Nice. Okay. There we go. Now that should also pull the contract. Good. Whew. Ah, thank you for checking the weather. Jesus, that's nice. Alrighty, so with that we should have the full focus tree API. Well, almost. Well, what we can still add is the element table, because that's another pretty easy one. twice. Oh. Mm. Ideally, you would have a table that's a table that goes both ways, you know. But eh. As in, it's a one-to-one mapping, or yeah. Ooh, now it's blowing my stuff off my desk. Ooh. Alright. Yeah, it looks like a storm, alright. Ooh. Oh my god. And Windows slam. Oh shit, hold on for a sec. Sorry about that. I had to rush out and take down one of the parasols we had set up against the sun because the storm was gonna take that shit with it. Okay, I'm good. I'm back though. Hello, I like to code. Welcome to the chat.
There's a storm brewing. I thought you guys were in the middle of a super heat wave.
We are, yes. we're just now, or we were the past week, we're getting better weather in the coming week. Okay. The only problem now is actually associating these elements. So, Also, I noticed a problem. Namely, this cannot be constructed like this. Or, The problem is, in order to construct a focus element, we need to create a focus tree, and in order to create a focus tree, we need to have a root, which has to be a focus element. So, parent needs to be allowed to be nil. This kind of puts everything in shambles, though. Because now the focus tree of all the children that we had are going to be nil as well. It's probably actually best if constructing a focus tree also automatically always creates an element at the root, so that we don't pass the root. At all. Also still need Whoa, what the fuck is this? Oh god, SoundCloud automatically goes to something new. That's not good. Oh jeez, I hope that doesn't get me copyright slammed now. Ooh boy. Gotta say, SoundCloud, not a fan. No, now we can accept the root. No, wait. Fuck. This is confusing. Okay. The problem is in order to currently create this chain of elements, this tree of elements, we're relying on the fact that we create things in the order of the tree and that the first element is already properly set up with its focus tree pointer. We just always copy that over. However, the tree also requires a root so that it can set itself up properly. But we can't do that because, yeah, okay. So the procedure has to now look something like root make instance holy shit. Actually, okay. And then at the end we have to... Or no, actually... We can do this here as well now.
Okay, so now the initialization contract is slightly different. Namely, you need to construct a focus tree first, and then create your first element and giving the focus tree as the parent argument. And after that, everything should be set up properly. Good. Glad I figured that out. Okay. Good. That handles that. And we're pretty much at the end of the stream now. Right on time, almost. Akidonov on Twitch says, "Oh shit, Lisp." Yeah. It is Lisp. Okay. Right, so this should be a complete focus tree implementation now, according to the sketch I have. Meaning that next time, tomorrow, we can look at the other part, namely the layout protocol. And once we have the layout protocol, we can take a look at the renderer and the general UI protocol. And once we have that, we should have the core protocols of Alloy implemented properly. Okay. Yeah, and once we do have that, we can start working on an actual layout manager implementation and an actual renderer implementation that draws things. I'm not quite sure yet what kind of renderer I...
Alloy is a pretty good name for an UI toolkit, by the way.
Thank you. I'm not quite sure what I want to do yet. It might be easiest to do a renderer that spits out SVG files. So an SVG renderer? I'm not sure yet though. I'll have to look at that. But you know, something that doesn't need to deal with resource allocation and whatever would be pretty good. Wow, things are rattling around like crazy. It's really storming now. Okay, let me just create a GitHub Git repository things. With focus protocol. Okay. Let me just create that repo real quick. Someone who uses an actual programming language in this section. Yeah. Okay. New repository. Oh, Lord. Zero list. Okay. Push that up. And we're there. Yeah, github.com/shirakumo/alloy or shirakuma.org/projects/alloy should be it. If you want to have another look over the code that I wrote tonight. Okay, right. So the plan for the next few streams is clear. Next time, layout, protocol implementation, and then after that, more other things, other protocol parts of the core, and then an actual backend implementation of both a layout algorithm and a rendering system. So that'll take a couple of days. Would probably assume the renderer and the layout are gonna take multiple days for each of those by themselves, so we're gonna be at this for a while. Yeah, okay. That's it for tonight. Thank you again to everyone who joined and stuck around. I hope what I explained so far made some amount of sense. And if it didn't, or if you have some kind of feedback, let me know. But yeah, check back in tomorrow for the other part of this. If there's no further comments or whatever, then I'm gonna head off and see that my house doesn't get blown off in the wind. I'm just gonna wait a minute.
Thank you for the stream.
Sure. Thanks for staying around. Okay. Alright. Good night, everybody. See you tomorrow.